All right, let's talk about tension. A 6 kilogram mass accelerates downward. So I've got an acceleration that's downward. Immediately I know that my downward force is bigger than my upward force. But let's figure out the specifics. So if it's a 6 kilogram mass, it's going to be m times g. So 6 times 9.8 as Fg. I think that's going to be 58.8. But 6 times 9.8, 58.8. So I've got 58.8 negative equals ma, but I've also got this tension. So I've got Ft going upward. So I'm going to have Ft minus 58.8 equals 6 times downward at 1, negative 1. Negative 6 equals negative 58.8. Ft equals 58.8 minus 6, 52.8. All right, now I wrote it in there just so I could fact check myself. The smaller force, 52.8, is pointing up. The larger is pointing down, causing it to accelerate downwards. So 52.8 should be my answer, and I'll have to update the answer key for that. Elevator moves downward, but slows. So it was moving downward, but it's moving downward less and less fast, which actually means it has an acceleration that is upward. Now, if it has an acceleration that's upward, that means that my tension, my cable that's pulling me upward, is larger than my force that's pulling me downward. So tension is greater than the weight. Two people pull opposite ends of a rope with equal force. Whoops, just a rope. The tension is, okay, well, this person feels an Ft that's going this way. This person feels an Ft that's going this way. And if they were ever not equal to each other, the whole rope would move that direction. But if they're just standing there, then Ft is equal to Ft. Each person feels the same force of tension. 10 kilogram mass lifted at constant speed has tension of, okay, when it says constant speed, what it tells me is that my acceleration equals 0. So 10 times 9.8, because kilograms, equals 98. So my tension must be 98 so that they're balanced. Ultimately, this comes down to F net equals ma. If my A is 0, then my F net must also be 0. Oh, that was the end of that one. That was the end.